This video covers section 4.5, solving mixture problems using systems of linear equations. Objective 2, set up and solve money mixture problems. Money mixture problems entails taking a set amount of money and breaking it up into two different interest earning accounts. Matthew received $8,000 for a Christmas bonus from his employer. He takes part of the bonus and puts it into an account that earns 3%, and the rest in an account that earns 4.5%. At the end of the year, he will receive $330 interest on his investments. How much money did Matthew invest in each account? The number of units in this case is the amount of money invested. The word we use for that is principal. The rate in this case is the interest rate or the percent. The amount that we're getting off of this is the interest earned. And so we know that the rate at 3% is 0.03 and at 4.5% is 0.045. How much do you invest in each account? In the 3% is X, in the 4.5% is Y. And we know that the total amount invested is $8,000. We know the total interest earned on the account. Total interest earned is $330. Now we fill in the amount of interest at the 3% rate by taking 0.03 times X. At 4.5% is 0.045 times Y. And now to make the equations. The equations come from the first column and the third column. The first column says that if you invest X dollars at 3% and Y dollars at 4.5%, the sum of those two, or the total of those two, has to make the $8,000 total invested. That would be what you call the principal equation. The other equation would be called the interest equation. So we see that the amount of interest earned at the 3% account is 3% of X. At the 4.5% account is 0.045 Y, and that total interest is $330. And those are our two equations. We solve these by using the elimination method. So I'm going to take the first equation, X plus Y is 8,000, and I'm going to create the opposite of 0.03 by multiplying it by negative 0.03. Negative 0.03x, negative 0.03y equals negative 0.03 times 8,000, which is negative 240. We keep the second equation at 0.03x plus 0.045y equals 330. When we add those two equations together, we get 0.015 equals 90. 0.015y equals 90. So y is equal to 90 divided by 0.015. Dividing 0.015 into 90, we take the 0.015, move the decimal over 3 spaces to the right. That means the 90 is going to get 1, 2, 3 spaces to the right as well. 15 goes into 90 6 times, and then we get the remaining zeros, which is $6,000. And that's why, so that's $6,000 at 4.5%. We invested a total of $8,000, so that leaves the remaining $2,000 at 3%. To check this, you would take 4.5% of $6,000, and that would be the $270 interest from that account, and 3% of $2,000 is $60. That would be the $330 in interest that we gained. So 6,000 at 4.5 and 2,000 at 3%. This leads me to your practice problem. I encourage you to press pause on your video and work this out and come back when you're ready to see the solution. It's dimes and quarters, so your rates are the value for one coin times the number of coins equals the total value. So please press pause on your video and come back when you're ready to see the solution. Okay, now that you've had a chance to work this out, we have dimes and we have quarters. And we don't know how many dimes we're going to have in the piggy bank. And we don't know how many quarters we're going to have in the piggy bank, but we do know there's going to be 85 of those coins. Now each dime is worth 10 cents and each quarter 25 cents. So the total amount then in cents of my dimes is 10 times D. The total amount of my quarters is 25Q. And the total amount in the piggy bank was 1,450 cents. The number of dimes plus the number of quarters is equal to 85. The value for all the dimes, 10D, plus the value for all the quarters, 25Q, is 1450. Solve this one by substitution. Multiply the first equation by -10, giving us -10D minus 10Q equals -850. Second equation stays the same. And when we add those together, we get 15Q equals 600. Divide both sides by 15, and that says that the number of quarters is 40. 40 quarters has a value of $10. There were 85 coins, so that leaves 45 dimes. Which is $4.50, which leaves us a total of $14.50. This concludes the video for section 4.5, solving mixture problems using systems of linear equations. Objective 2, set up and solve money mixture problems.